An exponential function has the form y equals b to the x power, where b is greater than 0 and b is not equal to 1. For example, y equals 2 to the x power is an exponential function where the base 2 is positive and is not equal to 1, and x is in the exponent. In this video, we will talk about 5 transformations of the graphs of the exponential functions. These are vertical shift, horizontal shift, reflection, vertical stretching and shrinking, and horizontal stretching and shrinking. So let's start with the vertical shift. In this figure, the black graph represents the function y equals 2 to the x power. This function has the form y equals b to the x power. This graph intersects the y-axis at 1 because 2 to the 0 power equals 1. The vertical shift tells us that if we add a positive constant c to b to the x power, then the whole graph will be shifted up c units. In this figure, the second function is y equals 2 to the x power plus 3. So, because 3 was added to the function y equals 2 to the x power, the whole graph was shifted up 3 units. So now any point on this graph is 3 units higher than any corresponding point on this graph. The vertical shift also tells us that if we subtract a positive constant c from the function y equals b to the x power, then the whole graph will be shifted down c units. In this figure, the black graph is y equals 2 to the x power, and the red graph is y equals 2 to the x power minus 3. So, because 3 was subtracted from 2 to the x power, this whole graph now is shifted down 3 units. The next transformation is the horizontal shift, and we get a horizontal shift when we add a positive number to x or we subtract a positive number from x. In this figure, we have the basic function y equals 2 to the x power, and the second graph is the graph of the function y equals 2 to the x plus 3. So, as you see here, 3 was added to x only and not to the entire function. Because of this, the whole graph now is shifted to the left 3 units. For example, if this point has the coordinates 0 and 1, then when this graph is shifted to the left 3 units, the point will have the coordinates negative 3 and 1. And indeed, when we replace this x with negative 3, then negative 3 plus 3 is 0, and 2 to the 0 power will be 1. So notice that if we add a positive constant to x, the graph is not shifted to the right, instead is shifted to the left. And now if we subtract a positive constant c from x, then the whole graph will be shifted to the right. So here again the first function is y equals 2 to the x power, and the second function is y equals 2 to the x minus 3. So because we subtract 3, then this graph now is shifted to the right. And if this point has the coordinates 0 and 1, when the graph is shifted to the right, this point will have the coordinates 3 and 1. The next transformation is the reflection about the x-axis and the y-axis. The function y equals negative b to the x power reflects the graph of y equals b to the x power about the x-axis. For example, here we have the graph of the function y equals 2 to the x power. Then y equals negative 2 to the x power is a reflection of this graph about the x-axis. So because of this negative, every value of y changes from positive to negative. So if this graph is above the x-axis, then this one is below the x-axis. But now if we put a negative only in front of x, then we will have a reflection about the y-axis. So here we have the graph of the function y equals 2 to the x power. then the graph of the function y equals 2 to the negative x power is a reflection of this graph about the y-axis. The next transformation is the vertical stretching and shrinking. If in the previous transformations the graph would keep the same shape, with stretching and shrinking, the graph will change its shape. If we multiply the function y equals b to the x power by a constant c, and this constant is greater than 1, then the graph will be stretched vertically by a factor of c. For example, in this figure, one function is y equals 2 to the x power, and the other one is y equals 3 times 2 to the x power. This is a number that is greater than 1, therefore, this graph is stretched vertically by a factor of 3. This means that to obtain this function, each y-coordinate of the first function needs to be multiplied by 3. For example, on this graph, when x equals 1, y equals 2, while on this graph, when x equals 1, y equals 6. So to obtain this y-coordinate, we need to multiply the y-coordinate of the first function by 3. And now if the function y equals b to the x power is multiplied by a constant c, and this constant is a number between 0 and 1, then the graph will shrink vertically by a factor of c. In this figure, one function is y equals 2 to the x power, and the other one is y equals 1/3 times 2 to the x power. To obtain this graph, we need to multiply each y-coordinate of this function by 1/3. And as a result, when a function shrinks vertically, the graph becomes wider. And now the last transformation is the horizontal stretching and shrinking. If in the function y equals b to the x power, we multiply x by a constant c, and this c is greater than 1, then the graph will shrink horizontally. In this figure, the graph of the function y equals 2 to the 3x is obtained by horizontally shrinking the graph of the function y equals 2 to the x power by a factor of 1/3. For example, in this function, when x is 3, y is 8 because 2 to the third power equals 8. Now, to get the same y-coordinate for this function, the value of x must be 1 because when x is 1, 3 times 1 is 3, and 2 to the third power will be 8. So then, we can say that the x-coordinates of this function are the x-coordinates of this function multiplied by 1/3. So this means that if we take this 3 and we multiply it by 1/3, we will get 1. And now when c is a number between 0 and 1, the function y equals b to the c times x horizontally stretches the graph of y equals b to the x power by a factor of 1/c. So here we have the function y equals 2 to the x power, and the new function is y equals 2 to the 1/3 x. This new function is stretched horizontally, therefore this function is wider. We can say that this graph is obtained by horizontally stretching the graph of y equals 2 to the x power by a factor of 3. And that is because when this c is 1/3, then 1 divided by 1/3 is 3. For example, when x is 3, the value of this function is 8. To get the same y-coordinate for this function, the value of x must be 9, because 1/3 times 9 is 3, and 2 to the third power will be 8. So outside of this window, this graph will have a point with the coordinates 9 and 8. So then we can say that the x-coordinates of this function are the x-coordinates of this function multiplied by 3. In other words, If we take this 3 and we multiply it by 3, we will get 9. So here we have all 5 transformations of exponential functions. I hope you enjoyed this video. Please subscribe, leave a comment, and thank you for watching.